we are dealing with today one of the important most chapters for JEE, that is current electricity. Most of you people might have seen the last year's paper. That of course is this year's only. I am talking of 2013 JEE paper. Most of the questions have appeared from electricity. That means his concentration totally or mainly is on electricity chapters. So one should have thorough knowledge about this particular chapter, and at the same time you people should have every concept related to this electricity topic. Not in fact one topic I am talking about: electrostatics, current electricity, electromagnetics, all the three put together. One should have complete idea and understanding about this particular topic. Then automatically you can score more in the final examination of JEE as such. So we are dealing with today some of the questions which have appeared in previous papers and which we people have felt them very, very important by model. Those concepts we people are dealing with today. I just start with the very first question, and remember all of you, as and when I read the question, while doing the question itself, while explaining the question itself, I'll deal with the entire theory, what is related to that particular concept as such, so that it will be useful to every student to understand the theory along with the solution of this particular question as such. That is the point. So let us start with the very first question as such. The VI graph for a conductor at temperatures T1 and T2 are shown in the figure. Then T1 minus T2 is proportional to, options are given this way. First option is given as cos 2 theta, second option is given as sin 2 theta, third option is given as cot 2 theta, and fourth option is given as tan 2 theta. In fact, this particular question, what we are taking up as the first one, is directly dealing with the relation between voltage and current. In fact, you know very well, the graph what has been provided to us, if you look at, current is given on x-axis, voltage is taken along y-axis. In addition to that, he has just given us two straight lines like this. This of course he has mentioned has been the graph when the temperature is taken as T1. This has been the graph when the temperature of the surroundings is taken as T2 respectively. And in addition to this graph, he has mentioned over here this angle as theta and this angle also as theta. This is the graph that has been provided to us. Now all of you should understand in this regard, when we deal with Ohm's law, then only we be able to understand the relationship between potential difference across a conductor and the current that is passing through the conductor. Just to recollect that aspect first of all of you know very well, at a constant temperature, when we people keep the temperature of the system constant, then the current across the conductor is directly proportional to the potential difference across the terminals of the conductor. In fact, all of you know Ohm's law, even though it may not be universal law, one can understand directly the exact relation between voltage and current whenever we consider a conductor as such. The more the potential difference across the conductor, the more is going to be the current that is passing through that. But one condition is to be mentioned carefully there, that is the temperature, which is supposed to be a constant. So exactly based on the same lines, he has made this particular graph. Look at carefully, all of you. This is the graph given at a constant temperature T1. The second line, whatever we have got here, the straight line, that is the voltage current relation when the temperature of the conductor is maintained at T2 degrees centigrade. That is T2 Kelvin maybe, because he is talking about both the temperatures given in capital letters as such. Capital letter of T, generally we refer to Kelvin temperature as such. We all know that one very well. So this is the concept. And this is the law by means of which this equation or this particular graph can be understood. If you take this way, you can understand that I is equal to V by R. In other words, V is equal to IR, we used to say. But all of you can understand from this, the slope of this particular graph. Slope is nothing other than tan theta, which of course gives you voltage by current, that is nothing other than resistance of the conductor. So I repeat once again here, the slope of VI graph that always provides us the concept of resistance of that conductor as such. What for means, mathematically speaking, slope when angle theta is taken with the x-axis, the slope is going to give us tan theta there. Tan theta over here is y by x, that is opposite by adjacent. Then automatically we can understand that is nothing other than the resistance part of it. So what you should understand from here, you look at first, I talk about the first straight line at the temperature T1. So what I can write here, the slope which is taken as tan theta. The slope here is nothing other than tan theta, is nothing other than resistance of this conductor. What for means, this tan theta is nothing other than R, V by I. So what is this tan theta here? It is no doubt V by I, which is resistance R. So what we should understand from this particular concept is, at this temperature T1, the resistance, if I take it as R1, automatically we can understand that R1 is nothing other than the slope which is equivalent to tan theta. But you can certainly understand R1 is directly proportional to absolute temperature there, because resistance is depending on temperature also. That concept also you people must have got in memory. In what way we people used to calculate the resistance at a particular temperature? Try to recollect that equation once again. I just remind you, R at a temperature T is equal to R0 into 1 plus alpha into T. This is the in fact relation between the resistances of a conductor at 0 degrees centigrade and at T degree centigrade respectively. If I take R0, the resistance of the conductor at 0 degrees centigrade, and RT, that is the resistance of the same conductor at a temperature T degree centigrade, then this in fact is the relation between the resistances at T degrees and at 0 degrees respectively. But you people all should understand one more point from this equation. What is it? Just look at this alpha carefully. That alpha, we generally call it as temperature coefficient of resistance. So what is that alpha called here? Temperature coefficient of resistance. So when we take temperature coefficient as alpha, remember carefully, alpha varies from material to material. That in the sense what? Copper, if I consider, its alpha value will be constant. Alpha value constant at that particular temperature, like we can think of, that is actually the concept. So if I take this slope is tan theta, which is proportional to R1 and which is proportional to T1. So what I can write directly from this point, please, T1 is proportional to tan theta. That is according to the first graph what we people are observing here at the temperature say T1 Kelvin. I hope you might have followed the first step here. Now check carefully the second straight line. This is also a straight line graph. That also is giving us the linear relation between V and I. That in the sense, when V increases, I also increases. And V by I remains constant at that particular temperature. So what we should understand now, this is angle theta. Look at carefully, I have made it very clear in the beginning. If angle is given with respect to horizontal, then tan theta becomes the slope. When theta is given with respect to the vertical, then slope becomes cot theta there. So what we should understand for the second one, please? Slope, which is cot theta this time, because this angle is given over here. That is proportional to R2. That is proportional to T2. So what we should understand from this one? T2 is proportional to cot theta. That is my second equation. So one should understand from this totally that at T1 Kelvin or degree centigrade, whatever you talk about, at T1 temperature, resistance is proportional to tan theta. At T2 temperature, resistance is proportional to cot theta. That is the concept. But what is it he is asking us to calculate? It is T1 minus T2 we just want. All of you understand carefully, one is tan theta and one is cot theta. Actually speaking, we just want the equation over here, that is T2 minus T1. What is this value of T2 minus T1? You just look at carefully. I can write this one cot theta minus tan theta. Observe this point carefully. Cot theta minus tan theta. What is a cot theta officially? Cos theta by sin theta minus sin theta by cos theta, which of course you can write cos square theta minus sin square theta by sin theta cos theta. See, simple mathematics. No physics is involved anywhere in this. The moment you have observed that T1 is proportional to tan theta and T2 is proportional to cot theta, the physics part of it is over. So you can say straight away understand cos square theta minus sin square theta, that is cos 2 theta as such. And all of you know well, sin theta cos theta we have. This sin theta cos theta, what do you find over here? This can be written as 2 sin theta cos theta divided by 2. That in the sense what? You can write sin of 2 theta divided by 2. This is the denominator. So what can we write now? This can be taken 2 cos 2 theta by sin 2 theta. You people all can understand cos by sin again is cot. So we directly can write 2 cot 2 theta. That is the value of T2 minus T1. But what is his question here? What is T2 minus T1 is proportional to what? That is the concept. So what can we write now? This implies T2 minus T1 is directly proportional to cot 2 theta. That is the equation. So what you people should understand from this? Whenever we consider Ohm's law, V and I graph for a conductor is a straight line passing through the origin. First point. Second thing, this particular straight line, whatever we are getting, depends on the temperature of the conductor. If temperature changes, automatically resistance also varies. When resistance changes, automatically the slope that is going to be changed, due to which we people are given here two different straight lines with two different slopes. Two different slopes means you should understand they individually are having two different values of resistances. That is the point what one has to understand. So if you just take up here, if angle theta is given with respect to the axis of current, remember this point carefully. If angle theta is given with respect to the axis of current, then slope becomes tan theta. If theta is given with respect to potential axis, then slope becomes cot theta. So in the case of T1, slope is proportional to tan theta, that is equal to tan theta. Here it is equivalent to cot theta. So automatically slope is proportional to resistance also. Therefore, we can now write resistance in turn is proportional to temperature. Therefore, T1 is proportional to tan theta and T2 is proportional to cot theta. Simple T2 minus T1. Come on, simplify that whole thing and you will be getting a cot 2 theta. So, what is the correct option over here? You just look at first. He has given 4 options over there. Cos 2 theta, sin 2 theta, cot 2 theta and tan 2 theta. These are the 4 options. Out of them, which one we people have got now? Third option, which is C, that is given, is correct. So, cot 2 theta is the corresponding answer for this T2 minus T1 over there. This is the first question what we have, right? So, all of you, the moment this type of a graph that comes over here, you should identify the relation between V and I according to the concept of Ohm's law. That is the only statement which relates voltage with current across any particular conductor as such. But one thing more I just want to extend over here. This alpha value whatever I have given you as temperature coefficient of resistance, its value, in fact you must have read also, alpha if it is positive, then one should understand it is a conductor like. If alpha is negative, we should understand it is a semiconductor like. And of course, all the conductors, they come under ohmic category of resistances. And all semiconductors and semiconductor devices, they come under non-ohmic category. So when you talk of these resistances also, you can easily recollect the fact that if alpha is positive for any material, it should be ohmic conductor or ohmic material. Suppose if alpha you come across with a negative sign by any chance, then one should consider that one as a non-ohmic resistance as such. So that way, ohmic and non-ohmic category also, those categories also, you people can remember here itself from this equation. So this is the description and this one the solution for the very first question what we people have taken up here in this sequence. So the answer over here is, that is the point what we people have to remember for this first question as such.